Yep. And also like we have a profit margin. In respect of profit margin, we can get the current balance of the account something. Okay. That is semi-additive. Coming to the non-additive, so profit margin is the column only one thing can be derived, something like that. So the profit margin of the branch, SBI branch or any bank branch or any policy insurance branch, organization bank. Oh, okay. That is called as non-additive. And based on these facts, right, we have a two types of fact tables, and that is called as a cumulative and a Snapchat fact table. Cumulative fact table is the example of additive fact, okay, and where it comes to like it is tells us the what has happened over a period of time, okay, what has happened over a period of time, over a period of time, and it is Snapchat is something like that. It's a example of a semi and the non-additive. It is a state of a thing in an instance of time. Like it tells us like what is the state of a thing in a particular instance of time. Okay, so this is called a Snapchat factor. Okay, so these are we have seen yesterday. Okay, and today we are going to see the dimension types. Dimension types. So we have a dimension tables like as like confirmed dimension, confirmed dimension, sorry, confirmed dimension and jink dimension and role playing dimension and degenerated dimension. Okay, and also like we have a slowly changing, we'll see tomorrow. Okay, slowly changing and fastly changing dimension, we'll see tomorrow. So also yesterday, as part of yesterday class, we have seen about the surrogate key. Okay, what is surrogate key? Because surrogate key is the global identification of a, okay, particular, sorry, global identification of a particular record in a database, right? So whatever, like if you are going to search for a particular record, right? So what implies like current record or something like that. Okay. So you have to fetch it through the surrogate key only. Okay. Surrogate key is a unique identification number in a data warehouse for a particular record. Okay. So that is called surrogate key. And instead of primary key, right? Here we are using the surrogate key. So primary key can be duplicated because it is not a primary key, it is a composite primary key, it's called. Okay, we will discuss later in detail regarding the keys. Okay, those are called as a constraints. Okay, so when we start SQL, right, we will discuss about the constraints. Okay, and coming to the confirm dimension. Confirm dimension is the dimension which like has a relation between the fact tables. We it will have two or more fact tables, even though it has a two relation between the two or more fact tables, but the behavior the definition of the dimension will not be changed. Okay, so this confirmed dimension will have a relation between the two or more fact tables, and even though the definition of the dimension will not be changed. What is the definition mean and what is the example for this is something. If you take an example of the, wait, if I take an example of the dimension table, one is the dimension table that is called as a dim customer, sorry, dim customer table. Okay, this dim customer table has a uh, data like generally it has a data like customer key. Okay, customer key and customer ID and customer name. We'll have a lot of things here. Like, so this is the customer key, which is this dimension table has a relation with the fact table called as fact sales premium. Okay. Or fact sales revenue or whatever. Okay. Whatever. So this can be a name of the fact table. Okay. So this fact table, it has a relation between the, because a customer, if you're going to look into the sales as revenue, right? So the customer information must and should be there, and you should have a customer key here, because we should know the revenue here. The keys will be like this: customer key and revenue. Revenue is the measure, right? Measures will be available fact table, as I said. Okay, so this has a relation between the this fact table. Okay, and same, I do have a one more fact table that is called as a fact product revenue. Okay, fact product revenue. Fact product revenue. Okay, so this has a fact product revenue. Here also we'll have a customer key and a revenue. Okay, so like this, we'll have a relation between the dim customer. This dim customer will have a relation between the two fact tables. Okay, and revenue is something like that. This is, here is the product cost. Okay, not a, and here is the revenue, something like that, the sale of the product. Okay, so in case of if the customer is customer took some product, right? So what is the sale amount, right? What is the product purchase amount? So you want to compare, like you, this dimension should have a relation between these two fact tables. Okay, even though even see something is changing in the dim customer, no, right? If the definition is same, like customer key is same, customer ID is same, customer name is same. Okay, this is called as confirmed dimension. This is the example of the confirmed dimension. Getting right? This is confirmed dimension. Okay. So this dimension table is the example, and we can have, and you can also say that if anyone asks you like a dimension can have a relation between the multiple fact tables. Yes, we can say like this. A one dimension can have a multiple a relation between the multiple fact tables, and that is called as a confirmed dimension. Okay, that is confirmed dimension. And coming to the next dimension is Jenk dimension. Jenk is something like that. So if we have a two tables, if we two dimension tables we have, okay, and these two dimension tables, like if you see in this diagram, we have one dimension table that is called as customer dimension table. Okay, this customer dimension table have one key, that is customer key, and this customer key is maintaining in a fact table. Okay, like this, if you have one more dimension that is a dim product, something like that, and that product key also you have to maintain in a fact table. So like that, so how many? So whatever the count of the dimension tables, the count of the keys of the dimension tables will be increased in the fact table. Okay, so suppose there is a two dimension table, we have to maintain a two keys in a fact table. Okay, so same thing, but if they are like increasing the fact keys in the fact table, so it may be cause of like performance issue to by selecting the data through the fact table to the dimension table. Okay, so instead of that, if we can combine these two dimension tables into one dimension table, and we can maintain one key into the fact table to improve the performance of fact table, that is called as a, we are combining one two dimension tables into one dimension table. That one dimension table is known as a chunk dimension. Clear? అర్థమైందా? సో ఏంటంటే ఒక డైమెన్షన్ టేబుల్ కి ఒక కీని ఫ్యాక్ట్ టేబుల్ లో మెయింటైన్ చేస్తాం. ఓకే, అలాగే ఎన్ని డైమెన్షన్ టేబుల్స్ ఉంటే అన్ని కీస్ మనం ఫ్యాక్ట్ టేబుల్ లో మెయింటైన్ చేయాలి. ఇలా కీస్ అనేది ఇంక్రీజ్ అయిపోయారు అనుకోండి, నెంబర్ ఆఫ్ జాయింట్స్ అనేది పెరిగిపోతుంది. సో నెంబర్ ఆఫ్ జాయింట్స్ పెరిగినప్పుడు సో సెలెక్టింగ్ ఏ డేటా, సో మనకు సెలెక్టింగ్ ఏ డేటా విల్ బి టేక్ సమ్ టైం. ఓకే, సో ద పర్ఫార్మెన్స్ విల్ బి స్లో. సో ఇన్ దట్ కేస్ ఏం చేస్తామంటే, సారీ,
నో కంటిన్యూ కంటిన్యూ.
ఓకే, ఇన్ దట్ కేస్ ఏం చేస్తామంటే వీఆర్ కంబైనింగ్ ద టూ డైమెన్షన్ టేబుల్స్ ఇంటూ వన్ డైమెన్షన్ టేబుల్. There is a probability, okay, we can combine those two dimension tables. So that dimension table is known as a Jane dimension. So if you want to know the example of this Jane dimension, we will go with that. Okay, so suppose I have taken one example of the table that is called as a marriage dimension. Okay, this is known as a dim marriage. Okay, so this marriage has the one marriage ID or marriage key also, it is fine. Okay, and here it is a marriage description. Okay, and some case like the description can be like something like married. Okay, and two is unmarried. Okay, this is one dimension table, and I'm going to take one more dimension table that is called as dim gender. Okay, so this dim gender has a data like gender key and gender description. Okay, DSA just written, okay, gender description, and the keys will be same like one and male and two say female. Okay, so now these two dimension tables will have a keys in a fact table. Like if you take in one fact table, right? So we have a fact table, and that fact table is contains two keys, like marriage key and gender key. Some other keys we can have like some customer key, whatever. Okay, as per the click path. So here we are maintaining the two keys by for the these two tables. But instead of this, can we combine these two tables into one table? Yes. How can we combine? Same thing I'm using. Okay. This is called as a dim marriage and gender table. Okay. And here I'm taking a key as a marriage and gender key. Okay. And here it is a marriage key, and here it is a gender, sorry, marriage, not a marriage key, it is a description, marriage description, and it's a gender description. Okay, now the keys will be like this one, and the person can be married. Okay, and he can be he's male. Okay, and then I'm going to second, the person can be unmarried or person or the employee. Okay, and he can male. Okay, and also the probability like married and female. Okay, and one more record, it's a unmarried
Female.
right. Like this we are combined. Now imagine like if we combine like this in a fact table, we can maintain only one key that is called as marriage gender, right? So this is how, if we are combining the two tables into one table, sorry. Okay. So two tables into one table, and this one table is known, this table is known as a Jeng dimension. This table is known as a Jeng dimension. Clear?
Yes, clear.
Okay. So this is what like a Jeng dimension. This is the perfect example to say about the Jeng dimension. So anyone ask you like about the Jeng dimension, just go with this example. Okay. And next dimension is, it's a, what is role play? Role playing is something like that. See, we have one dimension key. In a fact table, it has a relation between the one fact table only. But in fact table, that one dimension has a relation between the multiple keys in a fact table. Okay, multiple keys has a relation between the with the dimension tables only one key. Okay, example like if you take any like dim date dimension. Okay, suppose I'm going to take a dim date table. This is a dim date. Okay, and a dim date we have a okay. So here we have like a date key. Okay, so this date key has a relation with the fact table, fact sales, okay, fact sales, whatever premium or something. Okay, so this has a this has a case like just like order date key, okay, and shipping date key, okay, and same way like shipping date key and where it comes to delivery date key. Okay, and this date key has a relation with the order date key. It's playing a multiple rows in a single fact table. Okay, so and this date key also will have a relation with the ship date key, and this date key also having a relation with the delivery date key. Like this is a role-playing dimension. So one dimension key is playing a multiple rows in a fact table. Okay, so date can be like anything, like day, like month or year. Like order can be made in any date. Okay, and shipping date can be any day. The delivery date can be any day. Okay, so date can be anywhere. So anything. Okay, that is taken from the date key only. That is into the dim date. Okay, this is called as what it is called as. It is a role-playing dimension. Okay.
Role playing.
Yes, role-playing. Yeah, Pratyush, can you mute yourself or because I'm getting some background noise? Okay. So this is what role-playing dimension, which is playing a multiple roles in a factor. Okay. The next dimension table is a it's a degenerated dimension table. Okay. So degenerated dimension table is something like that. So we can take an example of same dimension table like it is called as a degenerate dimension table which is generated in a fact table itself. Okay, we have one column in a fact table that is acting as a dimension table which can be able to derive something from the dimension table. Okay, so we have one column in the fact table. That column, by using that column, right, we can derive something by using that column, and then that column is acting as a dimension. Example, like if you take a example of, I will take same sales table, or we can say in a fact sales trim is the table, okay, and this table has a like order key and like a shipping date key or something, okay, and whatever like it's a delivery date key or something. Okay, here we have a invoice number. Okay, invoice is the fact. Okay, invoice number is the fact. Okay, and this invoice number is act like a dimension table because by using this invoice number, you can derive something like that. How many product or sold in a particular day, right? So without having a relation with the dimension table, you can derive something by using this invoice number that is called as a degenerated dimension. This dimension is key is available in a fact table itself, even though this column is working as a dimension that is called is degenerated. So it is generated in a fact table that is called as a degenerated dimension. Clear? So till now, any questions? Role playing, degenerated, and whatever that gen dimension and conform dimension. Any questions here?
Last one, like
Okay,
degenerated.
right. This invoice number is what, right? So this invoice number is a fact. Okay, this should be maintained in the fact table only. Okay, but even by using only this column, right? This column, you can derive something. So that means you can analyze something like that. So how many products are sold today? Okay, number of invoice number is something like that. How many products are sold today? Right. So even anything, if you want to generally in a data warehouse, right? Anything, if you want to derive something, you should have a relation with the dimension and fact table. Here we do not have any dimension relation with this fact table, even though we are deriving something like that invoice number by using the invoice number, right? So here this invoice number is acting as a dimension table. That is called it is degenerated. Okay, itself is acting as a dimension. Got it?
Yes, yes, ma'am.
Okay, fine. So, and this is about the degenerate dimension. And next is like it's a fastly changing dimension. Generally, we capture the data which is in a data warehouse, right? What is changing along with the along multiple times. Like see, uh, so like data warehouse specifically focused for the capture the history data, okay, and the current data, and based on that only, suppose if you want to derive something like you will take the past records, right? So what is happened over the history, okay, last 1 year, what is happened and what our mistakes, what's our improve points or where the scope of improvement for us, okay. So these things if you want to analyze, you have to look into the last data, the past data, right? So that is what like a fastly changing dimension is also something like that where it is capturing the history of the data. Okay. But thing is that if you have like 1,000 columns in the table, and from this 1,000 columns, only two columns is changing every day. In it's not every day, like in a day, in a day itself, like we have a multiple times it has a change. Okay. So then we are separating out this instead of because of these two columns we are repeating this 1,000 remaining like 998 columns, right? We are repeating the data multiple times. So to avoid that thing, so we are separating these two columns into one table, and we are making that columns only loading into that table. Okay, how it should be, I will explain you with the example of one table that is a patient table. Okay, one is the patient table. Okay, here this patient table has a is it's like dim patient. Okay, I'm taking as a dim patient table. Okay, this dim table has a data like patient ID. First thing, like as a dimension table, it should have a key. Just remember, okay, every dimension table and fact table, it should have a keys. In data warehouse, the keys should be mandatory, and the keys are automatic generated one sequence number. Okay, it will not populate from any source. It will be a sequence number which is populating through the mapping. Okay, and it is like patient ID, and you can say name and date of birth, and we have a column like it's a BP, okay, and weight, okay, and we have some create data. We'll have it like create it, okay. So this keys has one, and patient ID is 102, something like that, 101 or 102, whatever. X is the name, and date of birth is something like that. BP, like see, this patient is in a critical ward, like he is admitted into the ICU. Okay, so in ICU, like generally the BP and weight will be observed multiple times, whether it is like after every 2 hours or 1 hour or something like that, right? So this is observed like when he joined, right? So it is like in a normal situation or something. And basically it will be abnormal, right? So because he joined in the hospital means it will be abnormal. He has like weight like 90 or something, 90 kgs or something like that. Okay. And the date will be like it's 13th03 and 2024. Okay. The next record is came and same like it's like sequence number is 2 and it is 102 and the X is the name and the same date of birth, okay, 2982 something like that. Okay. The name, same number. Okay. 87. Otherwise, I will write a one correct date. Correct. 020608 or something. Okay. Same date. But here it has some fluctuations, or it got stable now. We can see. Okay. And here the weight should be like 89 kgs or something. Okay. And here the date is here we have some timestamp here. Okay. So timestamp will be always denoted like this and PM something like that. Okay. Here 12 PM and it is same like 1303 and 2024 and the time will be like 2. Okay. So if you see that for every day, suppose the check will be happen for the 10 times. Okay. So only the check will be happen for only these two columns. Okay. Not any other columns like 1, 2, 3, 4. This create date will be changed. Okay, fine. So this, because of these two columns, we are repeating these other three columns or four columns. If there is not only three columns, we will have a lot of columns like other descriptive data like the phone number, address, location. Okay. So and also like whatever that's joining date or something like that, right? So everything will be repeated multiple times. Okay. Instead of that, what we'll do, we are we are changing these two columns into one column, other table. We are changing these two columns into other table. That is called as a one table, that is a patient key, patient patient data, whatever. Okay. We are changing this table to here and these two columns. And here we are maintaining one column that is called as a patient key. Okay. The key will be same here, 1, 2 only. Okay. Here, if you see, like here we are not going to maintain this entire row. We enter this data only once, okay? And this is going to be only, this is going to be joining date, okay? Created or whatever, join date. And here we will have a create date again. Create date, and this create date will be along with the timestamp, create date times, create date time, create date time. And this will be like 0303 and whatever 2024. I will copy this one and I will copy this one. Like this, we can enter multiple multiple records for only this column. So this is called as, this table is called as a fastly changing dimension. Okay, we are separating out the two columns which are fastly changing, right? The tables are going to be separate out as a different table, right? And that is called as a fastly changing dimension. Okay, got it. So these two tables, right? These two tables have a relation with the one table that is called as a patient and other tables. Here we will have a patient key and a patient ID. Okay, and here we have, instead of having the created here, right, we will have a created here. Okay, this is what so this is what is the fastly changing dimension. Okay na, అర్థమైందా? సింపుల్ ఒక డైమెన్షన్ టేబుల్ నుంచి ఫాస్ట్లీ చేంజింగ్ అట్రిబ్యూట్స్ ని తీసుకొని సపరేట్ టేబుల్ గా చేయడాన్ని fastly change dimension.
Yeah,
Okay na?
got it.
Fine.
Yeah.
Got it. So this is what fastly change dimension. This is also known as a rapidly changing dimension. Okay, rapidly changing dimension. And one more thing I forgot to tell, like factless fact table. Just a minute. Yeah, sorry. So fastly change. So whatever factless fact table. Okay. So factless fact table is something like that where there is no measures and facts in a table. Okay. But even though we have we can derive something from that fact table. Okay. Suppose like the example of the factless fact table. So we will have something like the employee key, and customer key, and also account key, something like that. We will have all the keys in a fact table only, and we do not have any other details. Employee key, customer key, okay, and account key, okay, and whatever like other keys, whatever date key or something. Okay, date key. Okay, so even though like we don't have a measures and the facts in this table, we have only keys. Even though we can derive something like number employee, and the customer, particular customer, right? How many accounts he has. Okay, how many accounts, how many policies created on a particular customer, on a particular number of accounts we can get, and on a particular date. Okay, or we can say like number of accounts on a particular customer and a particular date created. Okay, like this, based on this fact table, even though there is no facts and measures, okay, even there is no facts and measures, remember, even with only the keys, we can derive something by using this factless fact table. Okay, that is what like factless fact table is the one which is useful to derive something. Got it? Any questions here?
Yes. Basically, we don't have any fact table on factless table, right?
Sorry, I didn't get.
Like last one, factless table. Factless
Yes,
table.
factless fact table, yes. So we don't have any facts and measures here. Facts and measures. Facts is something like example is an invoice number. We don't have invoice number here. Measures is something like that premiums, amounts, right?
Mhm.
So that is also not here. Even though if there is no values, something like this facts and measures in a fact table, we can derive something, we can analyze something, right? So that is called as fact. So in generally in organizations, we don't see the factless fact table. Okay. In any project, like if you see like 99% project don't have a factless fact table. I didn't see in my experience a factless fact table, but it is an interview question where someone can ask you about the factors.
Mhm.
Okay. In if someone asks you, right, so you can still like I didn't see the factless fact table, but this is the knowledge I do have. This is something like where we have only keys, we do not have a facts and measures. And even though we can derive something, even though we can analyze something. Got it?
Yes.
Okay. So yeah, that's it about the factless fact table, first chain dimension, other dimension table. Slowly chain dimension we'll see tomorrow. Okay, in detail. So because our entire data validation ETL testing will be dependent on that. Okay, so we'll discuss in detail about the storage in dimension tomorrow, and after that the schemas. Okay, once schemas is done, right, we can end up this data warehouse classes. We'll move to the next topic. Fine. Any questions? If there is no question, we can wind up this call. Let me know
Sure.
if you have any question.
I don't have any questions.
Okay, Pradesh. Fine. Okay then.
Mhm.
Thanks.
Thank you. Bye.
Have a nice day. Bye.
Yeah. Sure. You too.